Hello and welcome to Golden Geography. Today we are going to be looking at the Amazon rainforest. It's part of the OCR unit on Earth's life support system. And we're going to be thinking a lot about how the water and carbon cycle are specifically adapted to the Amazon. So here's the spec. This is what we're looking for in this case study. We want to know a little bit about the water and carbon cycles and how they're adapted to the rainforest, specifically looking at the flows and stores, and they're really key. We want to know a little bit about the physical factors that affect these flows and stores within the rainforest. We want to know a little bit about the physical factors that affect the carbon flows and stores as well as the water ones. We want to think a little bit about drainage basins. So we're going to look at the Amazon drainage basin and some of the challenges that have in terms of natural fluctuations, but also human factors that are influencing it. And in regards of those human factors, what are they doing to both carbon and water flows? And then how we can manage them. How can we reduce the impact, particularly of the human activity in the rainforest? So we're going to start off with just thinking a little bit about the key features of a rainforest. We can see on the image here on the right that the rainforest has layers. Right at the very top we have emergence. These are very large trees that tend to emerge beyond the canopy. They're very distinctive, they stick out amongst the sea of trees that you get, and you can often see them on satellite images. We have the main canopy, and that's really key when we're looking at the water and carbon cycle and what that means for this biome. We have an under canopy, or sometimes called the understory, which are smaller trees. They might be juveniles that have not yet reached the canopy height, or they might just be species that are just a little bit smaller. We then have the shrub or herb layer at the bottom. And then we do also have the soils too that play a key part when it comes to the decomposition that we find taking place in our rainforest. So now we know a little bit about the structure, we need to think about what is happening with the water cycle. So if we think about an individual tree, say one within the canopy, that tree plays an important role. First of all, it acts as an interceptor. It will intercept rainfall, and in our rainforest regions we get a lot of rainfall, daily convectional rainfall. So here it's intercepting it. It enables that water to flow down the stem flow and gently into the soils beneath it, where it may be stored or maybe then taken up by the plant itself and used within the biomass for photosynthesis. If that happens, you will get evapotranspiration from the leaves within the canopy, and that will return as an output, return the water to the atmosphere, where it will then condense and fall as rain again. So there's a lot of flows within an individual tree, but there are some distinct stores as well. The canopy can hold water within the leaves. They're very often quite large leaves. They can be quite waxy and hold water. Some of them have actual drip tips in their design, so they can drip water if there's too much, to excessive amounts of water falls. We can store water within the soil and within the wood itself as a source of stored water. So individual trees play a really important role, both for flows and for stores. Once we start putting these trees together, the characteristics of one tree is then multiplied. So if we think about that canopy layer, where one tree will intercept, actually when you have multiple, they really do intercept and act like quite a significant barrier. There's very little water that will fall in the forms of rain and reach the ground. Most of it is going to be intercepted by that canopy. And that's good for the soil, because this is heavy, intense rainfall. If it did hit the soil, that soil could easily be washed away. So this canopy that intercepts the rainfall acts like a barrier and protects the soil beneath it. It protects the plants that beneath it, which are a bit more sensitive potentially, as they are more juvenile. You do get stem flow like you would have with an individual tree, but now you've got it with multiple trees. And again, that water will flow via stem flow and root flow into the soil, where the soil can hold it. However, there is an individual element to this that, when multiplied, can become an issue. So one individual tree, not a problem, all year round it will function well. But if you have this stem flow taking place, particularly during seasonal periods which experience intense rainfalls, can lead to flooding. Sometimes when you've got stem flow from multiple trees, there are issues where that water flow overwhelms the soil and you can get flooding, which in itself develops then a seasonal store, short-term store, which produces interesting dynamics in the Amazon rainforest. But it's that combination. One individual tree, not a problem. Multiple trees experiencing heavy rainfall and stem flow during heavy seasonal rain can cause issues. Well, what about the carbon cycle then? Same concept. On an individual tree basis, we have the leaves that are drawing carbon out of the atmosphere. They're using that carbon for photosynthesis. They are storing the carbon both within the leaves, the trunk and the roots, which is really beneficial. And in areas where we have quite high temperatures and lots of rainfall, like we do in a tropical environment where we have tropical rainforests, actually you can get quite a lot of drawdown, which is why often people refer to the rainforest as the lungs of the planet, because it's effectively drawing in that carbon and breathing out the oxygen that we need ourselves. So individually these plants are photosynthesizing, locking up carbon. They can help when it comes to the decomposition of matter, whether that be leaf matter or whether it's when the tree itself dies. That decomposition can add carbon to the soils, but really they're a good source of storage of carbon. If we look at it on a bigger scale, actually it's not just drawing down the carbon, but it's locking it up in those multiple stems, those multiple trunks, and in quite an extensive root network beneath the soil too. So when we're looking at multiplying it up, the ability to capture the carbon and to lock it up, potentially for long times within the soil, is really quite significant. And obviously depending on the species of tree, some of them might be a couple of 100 years old, some trees can be 1,000 or more years old, so that can be a significant period of time, even on a geological scale, when we're looking at geological time. So what are the physical factors that are affecting the water cycle? Well, we've got temperature, we've got geology, so the rock permeability or porosity, and relief. And we have a summary here. If we're thinking about temperature, the warmer the temperature is, the more evaporation or transpiration will take place. Also then, the more energy there is to create intensive heavy rainfall. So temperature very much affects those flows, those outputs and inputs into the cycle. There can be some stores associated with temperature. As I mentioned previously, there is the element of seasonal flooding, which can provide short-term stores, which ties into quite high temperatures and high in levels of rainfall. The geology, the rock permeability, the porosity, does play an important part. If we're looking at the Amazon, there's quite a lot of impermeable geology in the area, which ties into high levels of surface runoff, so therefore greater flows. Some areas don't have that, some have more permeable Geology, limestone and sandstone, which has greater porosity and water can flow through it a little bit quicker, but there are large parts which are impermeable. And then the relief itself, the Amazon has high relief. We've got areas of extensive highlands, the Andes, where that high relief enables significant surface runoff, so rapid runoff. But also there are some areas that are much lower, the basin of the Amazon, where you do get the flooding because that relief is much lower. And where you have that, particularly in the Pantella region, you can get that annual flooding take place. Well, what about the carbon cycle? Again, we've got temperature, here we've got geology, vegetation and soil. Warmer temperatures mean greater levels of photosynthesis, so more drawdown of carbon out of the atmosphere, which means there's more photosynthesis, so there's more storage of carbon. Vegetation itself, there's quite a high flow of carbon into the vegetation, whether it's the emergence, the main canopy, under canopy, there's a lot of vegetation, so a lot of net primary productivity. That means there's a lot of flow, a lot of movement, a lot of decomposition, but also a lot of photosynthesis. And there can be quite a lot of storage within that, carbon storage. The soils itself, they rely a lot on the decomposition, those warmer temperatures and that vegetation providing material and the conditions for decomposition. And that decomposition adds both nutrients into other carbon elements and water into the soils, providing them with that richness that provides the carbon and nutrients needed for the growth. The soil itself can store the carbon and other nutrients within it. That can be long-term, but on the whole is predominantly much shorter because of the rapidity of the carbon cycle, because of that climatic conditions. Again, the geology here, the rock here is predominantly igneous and metamorphic, which makes it quite hard, which means there isn't that much in terms of weathering or breaking down of the rock. So there's a limited role of carbon coming from those areas. So the flows out of the rock is quite limited where we have impermeable igneous or metamorphic rock. But where we do have those limestone areas, those sedimentary soils, that can release some carbon into the soil. Okay. So let's think a little bit about one drainage basin. We're going to focus on the Amazon. We want to think a little bit about some of the changes that the water cycle will have because of natural features. And those natural features really are seasonality. And what we're talking about here is something called the intertropical convergence zone. And you can see it here, two lines showing the difference between July and January. So it's looking here at the furthest north position and the furthest south. So you can see it kind of fluctuates around the equator. It doesn't have a massive difference when you're looking at northern areas of the Amazon and parts of northern South America. But if you do look across to Asia, Africa, there's a much bigger variance. And it's what brings very heavy rain. It's your seasonal monsoon rain, but it does influence the rainforest. So the rainforest will have convectional rain every single day, but when the ITCZ drops down and is covering the rainforest, the Amazon rainforest in January, it's when it gets its really intense heavy rain. And that's what overwhelms the ability of the plants to intercept and to have stem flow and root flow. That's when there's too much water and it leads to that seasonal flooding, those stores. So if we look at the Amazon itself, the areas on the image on the right, they're yellow, are relatively low-lying, and they're the areas that flood. Parts of the Amazon can rise more than 9 meters and can produce what is known as flooded forests. And these are areas where actually you can get dolphins We get very specific types of dolphins, river dolphins, that can come up into this area and change the scenery a little bit. But it's very seasonal, so this is not going to last all year, but it's a natural fluctuation where there are changes in both the flows and the stores within the rainforest. Well, okay, so we get natural variations. What about human factors? Well, as I'm sure you know, deforestation is a major impact. And if we look at the diagram here, we can see on the left of the diagram a normal rainforest, how it's recycling the rain. And then on the right, we can see what happens when you experience deforestation. Much more intense rainfall, much more intense evapotranspiration. You've got much more runoff, much more flooding taking place. The storage of water within the biomass is lost. They're very humid conditions that you get underneath the main canopy, where you get recycled rainfall, where you have those humid temperatures, that's lost. So we get significant changes to the rainforest, particularly those flows, because of human activity, because of deforestation. Well, if we're looking at the Amazon itself, there are estimates that between 1970 and 2013, that 175,000 square kilometres were lost per year. And this is where you can see satellite imagery where areas of the Amazon is rapidly disappearing. And they estimate about a fifth of primary forest, that's forest that's been untouched before, has been destroyed. And the consequences of that human activity is flooding. In 2014, the Madeira River flooded. It reached a level it never reached before, and it had an impact on the local community. Well, what about farming? The reason in many cases that areas are experiencing deforestation is for farming. Well, we can see there's a little bit of a scale here. Natural forests provide protection for the soil. They keep temperatures more moderate. We have humid environments, which is good for photosynthesis. As soon as you start to reduce that biomass, start changing trees to grass, well, temperature changes in evapotranspiration. And that's just small scale farming. Once you start doing commercial farming, where you are ploughing the land, where you've totally cleared it, well, actually you're going to have a much greater change in temperature and evaporation, and you end up with significant problems with your soil because you've got nothing holding it together year in, year out. You've got no biomass to hold it together. You've got no decomposition to feed the soil, and the water becomes, particularly in these tropical environments, absent. You can get areas which have loads of water and it's flooded, but that's very seasonal. But you can end up with areas that are very arid, and of course that's not good for agriculture. So what about the Amazon? Well, if we're thinking a little bit about farming, what is it doing? Well, there's two main types. You've got your cattle ranchers and you've got soya. They're the two big commercial types that have taken place. There's lots of other types of agriculture as well, but those are the ones that are having significant impacts, changing the flows and the stores, making those flows much faster, much quicker, and reducing the stores, which long term is not sustainable for agriculture. Well, what about the carbon flows then? Well, essentially the same thing. You are losing your stores here. Obviously your plant life is your stores, but you're also having problems in terms of the soil. It becomes exposed, it gets eroded by the wind, or if you've got tractors, mechanical equipment regularly going over it, that can erode it or can compact it, which has an impact on the nutrients in the soil. we're looking at agriculture, that can have an impact too. If you're looking at large scale cattle farming, those lands have been cleared, they've been seeded for grass, and the cattle are eating that grass. And as you can see in the picture, it's gone. Those soils are exposed. They are not going to be able to store any water. They're not going to be storing carbon within them. The nutrients in those soils are rapidly disappearing. Even though the cattle will be pooing and the poo adding to the soil, it's not enough. It doesn't replace the amount of decomposition by leaf litter. And where you have soya grown, because it's a monoculture, you have problems with pests and diseases, which means you need pesticides. And again, it can remove the same nutrient from the land, which strips the land of not all nutrients, but the specific ones that soya needs. So it can cause significant problems. So what can be done? Well, there are some strategies that are in place. The main one, obviously, if deforestation is the problem, then afforestation is the solution. And Brazil has done that. They are trying desperately to rebuild, replant, and also conserve, because what you put back is never the same as what was originally there. So legislation of primary forest is key, but also to reforest areas that have been degraded and to designate areas that are conserved areas, conservation areas, or protected zones. They can also change the way people farm, so educating people on better techniques, particularly diversity, so having 3 or 4 different crops that may use different nutrients and some that might even put nutrients back into the soil. Potatoes are great at fixing nitrogen, for example. Or there is something called regenerative farming, whereby you're looking at farming in a way that has less of an impact on the soil and in fact trying to regenerate the soil. But more of that later. Okay, so here's some quick questions. Pause the video and see if you can answer them. Here's your answers. And here are a couple of 10-mark questions that you might come across in an exam. You would expect to have a couple of paragraphs and you would need to have both knowledge and analysis in there, alongside some examples, if possible, from the rainforest or tundra, depending on the question. And here's an essay question, a 16-mark essay question that you might come across too.